In episode 28, titled Missing Data Types, MCAR versus MAR versus NMAR, and Correct Responses, the goal is to handle missingness correctly, because wrong assumptions break models, distort conclusions, and create silent fairness issues. DataX questions often describe missing values in realistic ways, and the scoring advantage goes to the learner who can infer why data is missing, not just notice that it is missing. Missingness is not a minor cleanup step. It is a signal about the data collection process, the population being observed, and the trustworthiness of inferences you plan to make. When you treat missing values as random noise without thinking, you can bias estimates, inflate confidence, or teach a model patterns that do not generalize. This episode will define the three main missingness types in plain language, show how to classify them from scenario clues, and then connect each type to the safest response the exam expects. The emphasis will be on disciplined reasoning and on communicating your choices, because stakeholders deserve to know how missingness decisions change outcomes. By the end, you should be able to hear a missingness scenario and quickly decide whether deletion, imputation, or a deeper intervention is appropriate.
Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series.
Missing completely at random, commonly abbreviated as MCAR after you have said missing completely at random the first time, means that the probability a value is missing is unrelated to both observed and unobserved values.
In other words, missingness is essentially random noise in the data collection process, like a sensor occasionally dropping a reading due to a transient glitch that does not depend on the reading itself or on other variables. Under MCAR, the cases with missing values are not systematically different from the cases without missing values, which means dropping those cases does not usually introduce bias, though it does reduce sample size. The exam may describe truly random dropouts, such as an occasional transmission failure that hits all devices equally, and those are MCAR cues. The critical point is that MCAR is the most forgiving missingness type, because it does not systematically distort the sample, even though it still reduces information. DataX rewards recognizing MCAR because it supports simpler, safer responses when the loss of data is acceptable.
Missing at random, commonly abbreviated as MAR, after you have said missing at random, means missingness is related to observed variables in the dataset, but not to the unobserved missing values themselves once you account for those observed variables. A practical example is a field that is more likely to be missing for users in a particular region, device type, or account tier, which you can see in the data you do have. In MAR, missingness is explainable using information already present, which means you can model the missingness process and often perform imputation in a way that reduces bias. The exam may describe patterns like older devices report fewer fields, or one channel does not capture this attribute, and those are MAR cues because the cause is tied to observed attributes. The key is that MAR still creates potential bias if you ignore it, because the missingness pattern is not random across the dataset. However, it is manageable because the pattern is visible and can be incorporated into estimation. DataX rewards recognizing MAR because it supports principled imputation and adjustment strategies rather than simplistic deletion. Not missing at random, commonly abbreviated as NMAR, after you have said not missing at random, means missingness is related to the unobserved values themselves, meaning the reason a value is missing depends on what that value would have been. A classic example is income being missing more often for very high incomes or very low incomes because those respondents choose not to report it, or latency values being missing more often when they are extremely high because the request times out before logging completes. In NMAR, the missingness mechanism is driven by hidden information you cannot fully infer from the observed data, which makes naive imputation and deletion risky. The exam may describe missingness that is tied to the value itself, such as the system fails to log when the event is severe, and those are NMR cues. The key point is that NMR is the most dangerous category because it can create strong bias and false confidence if you treat it as random. DataX rewards recognizing NMR because it signals the need for deeper action, such as improving collection, modeling missingness explicitly, or reframing the analysis.
Classifying missingness from scenario clues is an exam skill because you rarely get a label that says, "This is MCAR" in the prompt. Instead, you get context about how data is collected, who is more likely to have missing values, and what conditions trigger missingness. If missing values appear scattered with no relationship to any observed factor and with a plausible random failure mechanism, MCAR becomes plausible. If missingness is associated with observed fields, such as device type, geography, or time window, and you can predict missingness from what you see, MAR becomes plausible. If missingness appears when the missing value itself would likely be extreme or sensitive, or when collection fails under the conditions the missing value represents, NMAR becomes plausible.
The exam rewards you for using context because missingness is fundamentally about process, not about a single statistic.
You do not need perfect certainty. You need to choose the safest category given the evidence, and then choose a response that does not overclaim. When you practice reading missingness as a process story, you will answer these questions more reliably.
When missingness is plausibly MCAR and the data loss is acceptable, deletion can be an appropriate response because it simplifies analysis without introducing systematic bias. Deletion here means dropping rows or cases with missing values for the analysis at hand, or dropping a variable if it is missing too often to be useful. The exam expects you to weigh the cost of losing data against the simplicity and integrity of the approach, because deletion reduces sample size and therefore increases uncertainty. If the data set is large and missingness is truly random and sparse, deletion can be a clean, defensible choice. If the data set is small or missingness is heavy, deletion can cause power problems or change the sample composition in ways that increase instability. The best answer typically acknowledges that deletion is safest when missingness does not depend on observed or unobserved values, and when you can tolerate the reduced sample. DataX rewards this because it reflects disciplined decision-making rather than reflexively imputing everything.
When missingness is plausibly AAR and the structure supports estimation, imputation becomes a practical response because you can use observed variables to estimate plausible values. Imputation is not filling in values to make the spreadsheet look complete. It is estimating missing values in a way that respects relationships in the data and reduces bias from missingness patterns. The exam may describe missingness that varies by observed groups, which is a cue that imputation can incorporate those group patterns. A key principle is that imputation should be done in a way that respects evaluation integrity, meaning you avoid using information from the evaluation set to impute training values in a way that leaks patterns. Imputation also needs to match data types because numeric variables, categorical variables, and counts require different approaches and different constraints.
The exam rewards you for choosing imputation under MAR because it shows you understand that missingness can be managed when it is explainable from observed information. The safest framing is that you are using observed structure to reduce bias and preserve sample size while still documenting uncertainty and limitations. When missingness is plausibly NMR, the safest response is often to collect more data, change the collection process, or model missingness explicitly, rather than pretending you can infer the missing values from the observed data. In NMR, the missingness itself is informative because it is tied to what is missing, which means the act of being missing can encode the outcome you care about. If severe events are missing because the system fails under severity, then missingness is a severity signal, and naive imputation could erase that signal or create misleading stability. The exam may reward answers that recommend improving logging, adding instrumentation, changing forms to encourage reporting, or conducting targeted sampling to observe the missing values directly. Modeling missingness explicitly can also mean including missingness indicators and treating missingness as a feature, but only when it is defensible and when it does not create harmful shortcuts. The key is that you do not claim you can fix NMR with a simple imputation strategy because the missingness mechanism is tied to unobserved values. DataX rewards this caution because it reflects professional honesty about what the data can support.
Missingness can encode bias and fairness issues, which is why the exam may treat it as a governance concern rather than as a mere pre-processing detail.
If a particular group has systematically more missing data due to access barriers, device differences, or process failures, then models trained on the data may systematically underperform for that group. If missingness is related to socioeconomic factors or other sensitive correlates, the missingness pattern can become a proxy for protected attributes, producing unfair outcomes. The exam may describe uneven data coverage across segments and ask what risk exists, and the correct answer often includes the risk of biased conclusions and unequal performance. This is why documenting missingness and investigating its causes is part of responsible analytics, not just quality control. DataX rewards recognizing the fairness implications because it aligns with real-world accountability, where data gaps can create systematic harm. When you treat missingness as a potential bias mechanism, you make safer choices about modeling and evaluation.
A common and dangerous mistake is filling zeros when zero is meaningful and not missing, because it collapses two different meanings into one value. Zero can represent a real measured quantity, such as zero purchases, zero incidents, or zero latency at a baseline, and treating missing as zero can create false patterns. The exam may describe a field where zero has operational meaning, and the correct response is to avoid substituting zero for missingness without a strong justification. Substituting zeros can create artificial correlations, distort distributions, and mislead models into treating missingness as a real low value. In many cases, a missing indicator is safer than a zero substitution because it keeps missingness distinct from a true zero outcome. DataX rewards this distinction because it shows you understand data semantics, which is foundational for correct modeling. When you can say that missing and zero are different states and should not be merged casually, you are demonstrating exam-ready data hygiene. Documenting missingness choices is essential because stakeholders need to understand how your handling strategy influences results, uncertainty, and fairness. Documentation should capture what missingness pattern was observed, what assumptions were made about MCAR, MAR, or NMAR, and why a particular handling approach was chosen. It should also capture what impact the choice may have on interpretation, such as potential bias, increased uncertainty, or reduced coverage for certain groups. The exam often rewards answers that include documentation because it signals maturity and governance awareness. Documentation also enables reproducibility because missingness handling can change results substantially and must be consistent across training and deployment. When you document choices, you create accountability and make it easier to revisit decisions when new evidence about missingness emerges. DataX rewards this because it aligns with real-world practice where decisions must be defensible and auditable. In some cases, adding missingness indicators as features can be helpful because the pattern of missingness itself can carry information about the process. A missingness indicator is a flag that marks whether a value was missing, letting the model treat missingness as a distinct signal without collapsing it into a numeric substitution. This can be useful when missingness is MAR, because the missingness pattern relates to observed variables and can improve modeling robustness. It can also be useful in certain NMAR-like situations, but you must be careful because using missingness as a proxy can embed problematic shortcuts and fairness concerns if missingness correlates with sensitive attributes. The exam may ask what technique helps models handle missing values, and missingness indicators can be a correct answer when framed as a way to preserve information about missingness and avoid naive imputation. The key is to use indicators as part of a documented strategy, not as a hack to avoid thinking about the missingness mechanism. DataX rewards this nuance because it reflects responsible feature engineering under real data constraints. When you can say that indicators preserve missingness information while keeping semantics intact, you are using the concept correctly. A simple anchor that keeps these categories straight is that MCAR is random, AR is explainable, and NMR is driven by a hidden factor because that aligns the type with the safe response. If missingness is random, deletion may be acceptable when loss is tolerable, because it does not systematically bias the sample. If missingness is explainable from observed data, imputation can be defensible because you can estimate missing values using visible structure. If missingness is driven by unobserved values, you should assume a hidden driver and prioritize improved collection or explicit modeling rather than pretending you can recover truth from the existing dataset. This anchor also protects you from overconfidence because it reminds you that the hardest case is the one where missingness depends on what you cannot see. Under exam pressure, it gives you a quick sorting step that leads naturally to the correct mitigation. DataX rewards this because it makes your reasoning consistent, and consistency is what produces reliable multiple-choice decisions.
To conclude episode 28, classify one example and then pick the safest response, because that is exactly what the exam is testing in missingness questions. Start by stating what the scenario implies about the cause of missingness, such as whether it is random noise, tied to an observed attribute, or tied to the missing value itself. Then name the missingness type accordingly and state why, using the scenario cues as your justification rather than relying on guesswork.
Next, choose a response that matches the risk, such as deletion when MCAR and loss is acceptable, imputation when MAR and structure supports estimation, or improved collection and explicit modeling when NMAR is plausible.
Finally, state what you would document and what fairness risks you would watch, because missingness decisions change who is represented and how reliable predictions are across groups. If you can narrate that flow clearly, you will handle DataX missing data questions with calm, correct judgment and defensible responses.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.